Hey everyone, welcome back to the channel. Today, we're diving deep into something that's literally rewriting what we know about the universe, the James Webb Space Telescope. This incredible piece of technology has just delivered new discoveries that are blowing the minds of scientists everywhere. From revealing the oldest galaxies ever seen to capturing stunning images of distant exoplanets, the James Webb Telescope is pushing the boundaries of what we thought was possible. So, grab a seat, hit that like button, and let's unravel how this telescope just broke science as we know it. When scientists launched the James Webb Space Telescope, they hoped to peer further back into the universe's history than ever before. And it did not disappoint. Recently, the telescope detected light from galaxies that formed just a few hundred million years after the Big Bang, galaxies so ancient that their existence challenges current models of galaxy formation. This means our understanding of how quickly stars and galaxies came together after the Big Bang might need a major rewrite. The clarity and depth of these images are unmatched, showing clusters of ancient stars and gas clouds that existed when the universe was still in its infancy. For astronomers, this is like finding a missing piece of a cosmic puzzle that's billions of years old. The James Webb Telescope is not just looking at stars, it's literally looking back in time, showing us how everything began. One of the most jaw-dropping breakthroughs is Webb's ability to study exoplanets in detail. Unlike any telescope before it, Webb can analyze the atmospheres of planets orbiting distant stars. Recently, it detected signs of water vapor, carbon dioxide, and even hints of clouds on some exoplanets that could potentially be habitable. This discovery is shaking up the search for alien life because we now have the tools to find Earth-like conditions light years away. With its powerful infrared sensors, Webb can pick apart the chemical makeup of these alien worlds and help answer the age-old question, are we alone? This new capability is a game-changer for astronomers and could be the first step toward discovering planets that might one day host human life. Imagine finding another Earth. Webb is making that dream a real scientific possibility. The James Webb Telescope is also helping scientists understand the mysterious hearts of galaxies, black holes. By observing the dust and gas swirling around them, Webb is offering new insights into how these cosmic giants grow and interact with their surroundings. For example, Webb recently captured detailed images of a supermassive black hole's feeding habits, something that was impossible with older telescopes. These images show how black holes influence star formation and galactic evolution. This is crucial because black holes play a key role in shaping entire galaxies, including our own Milky Way. By studying these regions in unprecedented detail, Webb is helping solve questions that have puzzled astronomers for decades. It's like lifting a cosmic veil to see the engines that power the universe. Another amazing thing Webb is doing is revealing how stars are born. Its powerful infrared eyes can pierce through dense cosmic dust clouds that block visible light, allowing us to witness the birth of stars in real time. This is something the Hubble telescope could never do at this level of detail. Recently, Webb captured stunning images of stellar nurseries, places where gas and dust come together under gravity to ignite new stars. These new observations are helping scientists understand the exact conditions that create stars, planets, and potentially life itself. By studying these nurseries, we're learning more about our own solar system's origins and how common star formation might be across the galaxy. It's a beautiful reminder that the universe is constantly growing and evolving. So, what does all this mean? In short, the James Webb Space Telescope is forcing us to rewrite textbooks, rethink theories, and revisit long-held beliefs about the universe. Its discoveries are so groundbreaking that they're sparking new questions and entire areas of research. From the hunt for alien life to the origins of galaxies and black holes, Webb is making us realize that the universe is far more complex and mysterious than we ever imagined. And the best part, this is just the beginning. As Webb continues to scan the skies, we can expect even more surprises that will reshape how we see our place in the cosmos. The James Webb Space Telescope isn't stopping at stars and planets. It's also taking on one of the biggest cosmic mysteries, dark matter. While dark matter can't be seen directly, its presence is felt through its gravitational effects on galaxies and clusters. Webb's ultra-deep field images are allowing astronomers to map how galaxies are distributed and how dark matter holds them together. By studying gravitational lensing, when light from distant objects is bent by dark matter, scientists can trace its invisible fingerprints across the universe. This could finally help crack the puzzle of what dark matter actually is. For decades, researchers have theorized about exotic particles and hidden forces. Now, thanks to Webb, we have a front-row seat to the subtle ways dark matter shapes the cosmos. It's another huge step in revealing what makes up the 85% of the universe we can't see but know is there. Webb is also rewriting what we know about cosmic dust, those tiny particles floating between stars and galaxies. While it might sound unimportant, cosmic dust is crucial for forming stars and planets. With its advanced infrared sensors, Webb can see through dense dust clouds, showing where and how this material clumps together. By analyzing its composition, scientists are finding out how elements like carbon, silicon, and iron travel through space and seed new solar systems. Recent Webb data revealed unexpected amounts of dust in ancient galaxies, raising questions about how this dust formed so soon after the Big Bang. This finding means the life cycle of matter in the universe might be more dynamic than we ever imagined. For anyone wondering where the building blocks of life come from, the answers might just lie hidden in cosmic dust. Did you know that not all planets orbit stars? Some drift alone through the galaxy. These are called rogue planets. Finding them is incredibly hard because they don't emit light like stars do. But Webb's sensitive infrared eyes can detect the faint heat these planets radiate. This opens a whole new chapter in planetary science. By studying rogue planets, scientists hope to learn how planets can be ejected from their solar systems and survive alone in the cold depths of space. This could also reveal how common or rare our own solar system's stability really is. Discovering these lonely worlds may help us understand just how wild and unpredictable the universe can be. Galaxies aren't static. They move, merge, and collide. Webb's detailed images are giving astronomers a front-row view of these colossal cosmic crashes. By observing how galaxies interact, scientists can see how stars burst into existence when gas clouds collide and compress. Webb recently captured stunning visuals of merging galaxies, complete with streams of gas, dust, and newly born stars. These observations help explain how larger galaxies, like the Milky Way, came to be. Each galactic smash-up reshapes the structure of the universe. Studying these events can even show us what might happen billions of years from now when our Milky Way merges with the Andromeda galaxy. With Webb, the drama of the universe unfolds in real time. The James Webb Telescope is also giving us our first detailed look at weather patterns on distant exoplanets. By analyzing light passing through these planets' atmospheres, Webb can detect clouds, storms, and temperature changes. Recently, scientists used Webb to spot giant storm systems on gas giants many light years away. This means we can now study weather cycles on worlds that would otherwise be just points of light. Understanding alien weather isn't just cool, it's essential for figuring out which planets might be habitable. Harsh storms or runaway greenhouse effects could make some planets unlivable, while mild, Earth-like climates might make others prime candidates for future exploration. Believe it or not, the James Webb Telescope is putting Albert Einstein's theories to the test in ways never before possible. By observing how massive objects warp space and bend light, Webb can detect gravitational lensing with incredible accuracy. These cosmic mirages can help verify predictions from general relativity. In fact, some scientists are using Webb to look for tiny deviations that could hint at new physics beyond Einstein. The telescope's precision lets researchers check if gravity behaves the same across vast distances. Every measurement brings us closer to confirming or rewriting the fundamental rules that describe how the universe works. Star clusters are like laboratories for understanding how stars evolve. Webb is providing crystal-clear images of ancient and distant star clusters, some billions of years old. By analyzing these clusters, scientists can measure the ages of stars and see how they change over time. These snapshots help us figure out how elements spread throughout galaxies and how stars of different sizes live and die. Webb's ability to resolve individual stars and faraway clusters is giving astronomers new tools to map our galaxy's history and structure. Each cluster tells a story about the past, and Webb is making sure we don't miss a chapter. One of Webb's biggest missions is to find the very first stars that formed after the Big Bang. These so-called population 3 stars are thought to be massive, bright, and short-lived. They created the first heavy elements that seeded later generations of stars and planets. Finding these stars has been nearly impossible until now. Webb's deep infrared gaze is powerful enough to detect their faint glow, even across billions of light-years. Spotting these ancient giants would confirm theories about how the universe evolved from a dark, empty expanse to the star-filled cosmos we see today. The universe is connected by an enormous network of filaments made of gas, galaxies, and dark matter known as the cosmic web. Webb is helping to map these vast structures in unprecedented detail. By looking at the light from quasars and distant galaxies, scientists can trace how matter is distributed on the largest scales. Understanding the cosmic web shows us how gravity pulls galaxies into clusters and superclusters. It also reveals how matter flows through the universe, feeding galaxies and sparking star formation. With Webb's help, astronomers are piecing together the universe's grand design like never before. When massive stars die, they explode in spectacular supernovas, scattering heavy elements across space. Webb's advanced instruments allow scientists to examine the remains of these cosmic fireworks. By studying supernova remnants, astronomers learn how elements like gold, iron, and uranium are forged and spread throughout the galaxy. Webb's observations are giving us new insight into how these explosions trigger the birth of new stars and planets. It's like watching the cosmic recycling process that eventually led to our own existence. Each supernova remnant is a clue to how life-supporting elements travel across the universe. Closer to home, Webb is also studying comets in our own solar system and beyond. Its infrared sensors can detect heat signatures from comets too faint or distant for other telescopes. By analyzing their composition, Webb helps scientists understand what these icy visitors are made of. This reveals secrets about the early solar system, since comets are some of the oldest, most unchanged objects orbiting the Sun. Recently, Webb spotted comets coming from the distant Oort cloud, offering a glimpse into regions we've never directly observed. Each new comet Webb finds is like opening a time capsule from the solar system's birth. The James Webb Telescope isn't just for distant galaxies, it's also taking amazing shots of moons in our solar system. From Jupiter's volcanic moon Io to Saturn's icy Enceladus, Webb's detailed views reveal surface features, geysers, and possible signs of subsurface oceans. Scientists hope to use Webb to search for plumes of water vapor or organic molecules that could hint at life beneath these moons' frozen crusts. This is opening new frontiers in the search for habitable worlds right in our cosmic backyard. Stellar winds, the streams of charged particles flowing from stars, shape their surroundings and influence planet formation. Webb is giving astronomers their clearest look yet at how these winds blow through space. By analyzing the light from young stars, Webb can measure how fast and powerful these winds are. This helps scientists understand how they clear away gas and dust in star-forming regions, making room for new planets to form. It's a delicate cosmic dance that determines the fate of entire solar systems. In recent years, scientists have picked up strange signals from space, like fast radio bursts, FRBs. While Webb can't detect radio waves, it helps pinpoint the galaxies these signals come from. By doing this, Webb can help solve the mystery of what causes these intense, brief flashes. Are they from neutron stars, black holes, or something even stranger? By connecting these signals to their cosmic homes, Webb brings us closer to solving some of the universe's weirdest puzzles. Beyond the science, the James Webb Space Telescope is inspiring people worldwide. Its stunning images and groundbreaking discoveries remind us how much we still have to learn about the universe. Schools, museums, and science centers are using Webb's data to spark curiosity in young minds. Future astronomers and engineers are watching this mission and dreaming of what comes next. Whether it's sending humans to Mars, building better telescopes, or searching for life beyond Earth, the legacy of the James Webb Telescope is just beginning. The success of the James Webb Space Telescope isn't just about what it discovers today, it's shaping how we plan tomorrow's missions. Engineers and astronomers are learning from Webb's technology, like its massive sunshield and precise mirrors, to design even more advanced telescopes. Future missions could look deeper into black holes, capture images of Earth-like planets in other solar systems, or study the birth of stars with even more detail. Some of the lessons learned from Webb will also help develop instruments for potential missions to Jupiter's moons, Mars, or even interstellar probes. By pushing the limits, Webb is paving the way for the next generation of cosmic explorers. Closer to Earth, Webb is contributing to our planetary defense. Its infrared capabilities help astronomers study asteroids that could pose a threat to our planet. By precisely measuring their size, shape, and composition, scientists can better predict their paths and understand how to deflect them if needed. Webb's detailed observations of asteroids and near-Earth objects are another example of how this telescope isn't just about distant galaxies, it's helping keep our home planet safe too. Knowing the distances to stars and galaxies is key to understanding the scale of the universe. Webb's precision instruments help astronomers refine the cosmic distance ladder, which uses standard candles like Cepheid variables and supernovae to measure vast cosmic expanses. More accurate measurements mean better estimates of the universe's age, expansion rate, and ultimate fate. Webb's contribution here could help resolve debates about the Hubble constant, a key number that has puzzled astronomers for years due to conflicting measurements. One of Webb's standout abilities is watching planets form around young stars. These protoplanetary disks, swirling clouds of gas and dust, are where new worlds are born. Webb can capture details like gaps and rings where planets are clearing paths as they grow. Seeing planet birth in real time gives scientists a clearer picture of how systems like our own formed billions of years ago. It also shows how common, or rare, solar systems like ours might be throughout the galaxy. The search for life hinges on finding the right chemical building blocks. Webb can detect organic molecules like methane, carbon dioxide, and water vapor on distant planets, comets, and moons. Recently, Webb detected complex carbon molecules in unexpected places, raising questions about how widespread the ingredients for life might be. This capability turns the telescope into a powerful tool for astrobiology, helping us figure out where the conditions for life might exist far beyond Earth. Gravitational waves, ripples in space-time caused by massive cosmic events, are another frontier of modern astronomy. When observatories like LIGO detect a wave, astronomers scramble to find the source. Webb's powerful imaging can help confirm these origins by spotting the visible or infrared aftermath, like when two neutron stars collide. By combining gravitational wave detections with Webb's sharp eyes, scientists can piece together a complete picture of some of the universe's most violent events. Brown dwarfs are objects too big to be planets, but too small to sustain nuclear fusion like stars. They're cosmic oddballs that help bridge the gap between planets and stars. Webb's infrared vision makes it perfect for spotting these dim objects, which can be hidden in star-forming regions or drifting alone through space. Studying brown dwarfs helps scientists understand how stars and planets form and where the line between them really lies. Stars live for millions or billions of years, but their final moments are some of the most dramatic events in the universe. Webb is observing dying stars shedding their outer layers, forming beautiful planetary nebula. These colorful clouds of gas and dust enrich the galaxy with elements that go on to form new stars and planets. By studying these final stages, scientists learn about the life cycles of stars like our Sun and what will happen to our solar system billions of years from now. Quasars are incredibly bright objects powered by supermassive black holes at the centers of young galaxies. They shine so brightly that they can be seen from billions of light years away. Webb is finding some of the most distant quasars ever detected, helping scientists understand how black holes grew so massive so quickly after the Big Bang. These discoveries are giving clues about the early universe and the role of black holes in galaxy evolution. Some galaxies are bursting with star formation, producing hundreds of new stars each year.
These starburst galaxies are cosmic fireworks shows, and Webb's detailed views are helping scientists figure out what triggers these massive bursts of starbursts. By examining the gas, dust, and interactions in these galaxies, astronomers hope to understand how star formation can suddenly ramp up and then slow down. This also sheds light on how galaxies evolve over billions of years.
Webb's sensitivity to water vapor is uncovering water in places we didn't expect, like in the atmospheres of small rocky exoplanets or hidden inside dusty disks around young stars. Detecting water is one of the biggest steps toward finding habitable worlds. Every new detection gives scientists more data to compare with Earth and helps refine our search for planets where life could thrive. Imagine being able to watch seasons change on a planet light years away. Webb's long-term observations can monitor how atmospheres on exoplanets shift over time. This helps reveal how climates work under alien suns. By tracking temperature changes and chemical shifts, scientists can learn how stable or extreme these worlds might be, crucial for deciding where to focus the search for life. Webb is also ready to catch transient cosmic events, like when two neutron stars or black holes collide.